Okay, let's get started. We are headed into the last big topic of the semester, which is structs and classes today. And the rationale or the motivation for today's topic and for the next week and a half that we'll be covering them is that thus far, we've seen one way to organize collections of information. If we have a set of weights or a set of scientific observations, then we may want to organize them as an array or a vector. And that is fine as far as it goes, but we know that in real life, we encounter a lot of situations where we would like to organize some information, but it's not information that all has the same type. For example, if I want to record the information on a driver's license, then it doesn't have homogeneous data. Like, it's not all strings, it's not all chars, it's not all numbers. If you look at your driver's license, you'll see it has your name on it, your first name, your middle name, your last name. Has probably your social security number. It probably has your street address, which has a number, then the street, then there's the city, the state, and the zip code. Zip code's a number, but the city and state are strings. Most likely has some code for your eye color, which may be an integer or a character. It may have your gender on it, which would probably be a character. It probably has certain restrictions. For example, for me, I have restricted vision, so there's going to be that code on it. Whether I'm an organ donor or not, that may be a true-false thing. So I would like to keep all this information about a driver's license in one area, and we haven't given you a way to do that, but today we will via something called structs and classes. Now, in general, you will hear this kind of data structure referred to as a record, okay? Because we're used to records, right? We have our health records. We might have our records here at UT for our transcript as a record, okay, of our grades. So we often talk about records, and structs and classes, they're two different ways C++ provides to basically hold the information in a record. And then, of course, we typically maintain a file of records. If I'm the registrar here, I keep a record of each student's transcript. So I would still probably in a program need to use a vector to hold all my records, okay? So that's where we're going today, and on Thursday and next Tuesday. So we're going to start with structs because they're the simpler version of a record, and they originated in the C language. They were adopted with some modifications into C++. They allow us to store a collection of logically related data values. So I just gave you the example of a driver's license. Another example might be a music album, where you want to keep track of the title, the artist, perhaps a vector of members. If it's a band, you would like to have all the members recorded, the release date, which might be an integer, and a vector for the titles of the tracks on that album. So those are two examples where you would like to be able to hold information about some kind of object, and it's a group of logically related data values, but the types of the data are different. Okay, so the way, actually let me not use that just yet. Today's actually a lecture. It was one of the few times I don't have a video lecture for you. So, Okay, so this is what the declaration for a struct looks like. It starts with the keyword struct, and then it gives its name. And then after that, we list what we call the fields or member variables in that struct. I'll refer to those interchangeably. The C++ way of referring to them is typically as member variables, but the C way is to call them fields, and the way you probably think of a record is you think of fields in a record. So I will use the two terms interchangeably. In this case, this student struct has three member variables, one for the student's name, one for the major, and one for the student's GPA. You can see that the declarations of the variables or fields are just like in a normal variable declaration. They're between curly braces, and at the very end is a semicolon, which is important. If you forget the semicolon, you'll get some error messages from the computer that may or may not be particularly intelligible because it won't always say you're missing a semicolon. Okay? So these declarations go at the beginning of your program. So after the include statements, before your function declarations. So they're essentially the second item in your program after the include statements. You might put your constant declarations before them as well, but they're certainly in what we call the preamble of the program. So there you go. In fact, here I did put the const declarations before the struct declarations. So they would be the third item in your program, but they definitely go before your function prototypes. The reason is that your function prototypes often will take structs as parameters, and a struct must be declared before it can be used. Okay? So one nice thing about structs is that they divide what we call the namespace. Okay, the namespace up to now has been kind of this big global entity. It's not quite true. Each function, you're allowed to reuse variables. So if you have main and you have a function foo, you could use the same variable name in both of them. For example, I could have a string name in both of them. Okay, so that's kind of this whole thing is called a namespace. It's the set of names that can be used in a program. And within structs, we are also able to reuse names for fields because we always provide the struct as context. So here, for both student and staff, we have their name and address, and then we have some additional information for each of them. But the key thing is you don't have to dream up unique names for your member variables in different structs. Now, within the same struct, clearly, you need to have unique member variables. It wouldn't make any sense to have two member variables with the same name because that just creates confusion. Okay, so have a clicker question. Actually, not yet, just a second. Let me see, maybe I do. No, sorry, false alarm. I don't. Yes, I do. Let me bring up the PowerPoint slide for it. Okay, so there's your option. So answer that clicker question. Okay, going to give you 5, 4, 3, 2, 1, 0. Very good. So I had not actually told you how you shove a vector in there, but that is the way you do it. It's just like any other variable declaration. So this presumably is some record of a person's bank account. Okay? And the vector is obviously keeping track of their deposits. Okay, so we've shown you how to declare a struct. Now let's say we want to use a struct in our program. It looks just like any other variable. You put the name of the struct and then the name of the variable, or a comma separated list of variables. So it looks like just any other variable declaration. And you don't have to put the word struct in front of it, it's just student. And in effect, the struct declaration creates a new type that you can now use. So structs are often called user-defined types because they create a new type for you. And if we want to assign values to member variables, we need to give, obviously, the name of the student. Well, I'm sorry, the name of the student variable. But then we have to indicate which field we wish to assign the value to. So we do that by giving the name of the member variable. And we need a delimiter to indicate where the member variable name starts and the name of the variable stops. So in this case, we use a period. So it's st.name equals John. And if we want to assign to the GPA, it's st.gpa equals 4.0. So prefix the member variable name with the name of the struct variable and a dot. Okay, I see a lot of students initially trying to do this. They'll say student.name equals John. And the problem with that is student is a struct declaration. It's a type. The computer has no idea what you're assigning to. It has to be a variable that you assign to. So this is no good. Okay, so we have a couple more now. So take a crack at this one. There is obviously 4 is wrong. Okay, going to give you 5, 4, 3, 2, 1, 0. Very good. So it is student and then next student. So the name of the struct and then the variable name. Next question. Okay, so suppose I have this set of declarations right here, and I want you to assign the last name field of next student to name. So it's going to require you to do a little generalization from what I just told you. Okay, I'm going to give you 5, 4, 3, 2, 1, 0. Very good. So you're still using that dot notation to access the member variables in the struct. And again, you got to get used to us saying, how would I assign the last name field of something to name? So when we say to, that's the thing that appears on the left-hand side. The right-hand side is what we're assigning. And we have next student is the variable that contains the information. Its member variable is last name, and so that's what gets assigned. Charles.
So is the concept of assigning a variable to a struct the same as assigning a variable to a file name? Maybe?
A variable to a file name. But you don't really assign a variable to a. When you say assign a variable to a file name, do you mean write a variable? But do you mean write a variable to a file stream, or do you mean to associate a variable with a file? It's like associating a variable with a file string. That's a good way to think of it. It's a perfect way to think of it. Yep. So it's associating a variable, in this case, with a certain kind of object. In this case, you're saying next student should be basically an object. So you can think of student as an object that contains these elements. So in memory, the way it would look is that a chunk of memory gets assigned to next student. And conceptually, it has a last name and a first name. And then might be like Smith and say Mary. Okay, so in memory, it's just a chunk or block of memory, and the member variables are physically stored with each other, just like on a paper form. If it helps, think of a struct as just a lot like a paper form. Like, you know, when you fill out an application for a driver's license or on an album cover, you see, it's just a lot like a form conceptually. So if that helps you to think of a record or a struct as being like a form, that's a good analogy. Other questions? Okay, let's see if I have any more. Okay, so we have gotten through that part. Okay, so the next part is by itself, a struct isn't particularly helpful. If I just need to process one driver's license at a time, and I don't need to store that information in memory afterwards. Let's say I'm reading in driver's licenses one at a time, and all I'm doing is checking to see which ones have an eye restriction that requires corrective vision. And if the person needs to have corrective vision, I print that name out, I read the next driver's license. Well, there's really no reason in that case to declare a struct. I could just declare a set of variables to hold the items of the driver's license. The real value from a struct is just like what happens in the real world. In the real world, we keep files of records, right? We keep files of transcripts. We keep files of health records. We keep files of driver's licenses. For those of you who are music buffs, you might keep files of your music albums. So we typically are dealing with files of records. And when we read these records into memory, we need a way to store these records. Well, we have a mechanism for doing that. It's really a file, it's really just a big list of things. So we typically will use a vector to store our records. Well, just like you can use a vector to store ints, or you can use a vector to store strings, you can use a vector to store structs. So here I have a vector of students. Okay, so if you remember a few slides ago, I said that a student want to use this struct declaration for a student, a name, a major, and a GPA. So a vector of student objects looks something like this. Okay, it still has the index entries. Okay, let's say we don't bother with the end of it. But then each one is an object. So in this case, we have name, major, GPA. So the name might be Bill. Major might be CS. GPA might be 3.61. Okay, next one. Name, Mary, and major, say again CS, GPA 3.8. Okay, maybe another one. Name, Smiley. Yes, my dog made it in. Major, we'll make her a double E major. And GPA, well, she is a dog after all, so she gives it a good effort, but not quite as good. Okay, so, but hopefully you get the idea that each entry in the vector is storing a record or an object. Okay, again, they're synonyms. So the first entry, the student is Bill, his major is CS, his GPA is 3.61. The second entry, the student is Mary, her major is CS, her GPA is 3.8. Okay, so we need a way to add students to our vector. Okay, this way that I've shown you here is the first way. So I declare a second variable which is capable of holding a student record. And then I use my typical while loop to read one line at a time, and I'm assuming in this case that my lines contain students, their major, and their GPA, so it would look something like this. These are my input, looks something like that. I'm reading it from standard in. How do we know I'm reading it from standard in? CN. So I'm going to start using the word CN because as you get into CS 130 and 140, that's how we refer to input that comes from what we call the console. We call it standard in. and we read it using CN. Okay, so just like regular reads, we give the variable names, but in this case, as we read into each individual member field, we have to give its name and the object it's associated with. In this case, st.name, st.major, and st.gpa. So that would fill st. So remember, st itself has 3 fields: a name, a major, and a GPA. So the first time I do the while statement, I read in Bill. The major is CS. The GPA is 3.61. Then when I do this pushback right here, it automatically creates a new entry in the vector. So in this case, the vector would be starting from scratch. So it would create the first element and copy in the values from ST into the first entry. So unlike an array, you can't assign one array to another, but you can, in effect, assign one record to another record, one struct to another struct. Okay, so after the first iteration, this is what our vector looks like. Then it comes back up to the top, and it reads the second record, which is Mary, and now we get in ST, Mary, CS, and 3.80. Then we come down to our pushback, and it adds a new entry down here with name Mary, major CS, and GPA 3.8. Okay, so again, we're passing as a parameter to push back the ST variable. So each time we're copying a new object into the vector. So questions about how we do that? We good with that? Okay. Let's see if we have so I feel like I skipped a slide. I didn't skip a slide, but there is one thing that I didn't make clear. So let's say that I had another student up here. Let's call it ST1. You're allowed to do this type of assignment. So this is a legal assignment. You couldn't do that with arrays, but you can do it with records, with structs. So that will assign or copy the contents of ST to ST1. Okay. I feel certain I have a slide on that, so I'm just going to pop ahead for a moment. I felt like I had a slide, but there we go. So we will get to what is meant by this in parentheses, but just like you saw with strings, the ability to assign a set, there's a way to initialize a struct all at once, and we'll show you that momentarily. Well, actually not momentarily, toward the end of the class. But then you can do this assignment, and it simply copies the contents of S1 to S2. We have, yep. So when we execute that statement S2 equals S1, it assigns the contents of S1, it copies them into S2. So it's a complete copy. It's like giving you a second form. Remember I said you could think of these records like they're forms. It's just like giving you a blank form and you just look at the first form and you copy the contents of the first form into the second form. And then if you change the member variable in the second object, it only changes it in the second object. So if I reset S2's name to Amy, it changes it in S2, but you see that the name in S1 is unchanged. So it's just like literally copying into a second form, and then if you change something on the second form, it doesn't affect the first form. Okay? Okay. So, let's see. Yes. Okay, so we now will check this out. We have another clicker question where we can check your understanding. Okay, so just a second. Try to write this one down. I actually don't have a clicker questions for this one. So try to write, this is fine. Try to write this one actually down, either in a notebook or on a computer. See if you can do this now. Before, I made you recognize whether you could do it. Now see whether you could actually write it out. Okay, so I am assigning the string Cardiff to the field road name in BVZ adder. So BVZ adder is my variable name. And I then use a dot to separate it from the road name. And I assign it Cardiff. So questions about that? Anyone having trouble with this? Okay. So now we have a couple clicker questions involving vectors. Okay, going to give you 5, 4, 3, 2, 1, 0. Outstanding. All right. So it's just like adding any other type of variable to a vector. You use the pushback function and you give the name of the variable. Okay. So here's our next one. So it's kind of similar to the previous question with assigning Cardiff, but now you have to do it to something that's in a vector. And again, I know this is a little bit of a generalization, making you stretch a little here. Feel free to talk about it with your neighbors. So we're assuming that this element already exists. That's a assumption here. We assume that the third element already exists in the vector. Okay, going to give you 5, 4, 3, 2, 1, 0. Very good. So it's just you retrieve the object, so this part right here, the first part before the dot, retrieves the appropriate object. So if we go back to this example, and we'll add back here 2 for Smiley. When you say address book 2, that gets you this object right here. Now the dot road name, I know there's no road name here, but it gets you the specific field within that object. You do not put the name of the struct in the middle. The compiler, all semester long, I have said that the computer is pretty dumb, but it's not that dumb. It knows that the object you're retrieving is an address object. Therefore, it is unnecessary to put address in there. And it will flag it as an error if you try to do so. The only place where you use address is when the name address is when you declare the struct or when you declare a variable of that type. But when you're using an object of type address, you'll never see the word address used. Okay? So questions about that? Okay. So just a few other things. It is in the real world, you typically have a form is divided into parts, right? So if I am, let's say that I am checking out of Amazon, and actually I'm a new member. Let's say I'm signing in as a new member and it's collecting information about me. It'll first collect information about my personal information, name, address, city, zip. Then it may collect some information about my credit card. Then it may collect some information about my interests or about my date of birth. So you may have a form, and in effect it has subforms. So we need to be able to model that in a computer. And the way we do that is we allow there to be structs nested within other structs. So for example, in a real struct for a student, we might keep your date of birth. We might want to keep a transcript of the courses that you have taken. So it makes sense to actually group a date, like a birth date, into a month, day, and year. And it makes sense to organize information about a course into a record, such as the course code, the title, the building, the room number, the time. So we can nest. Here we have date of birth, which is a date, and we have a vector of courses, both nested within a student struct. Now, it is important, if you're going to use date and course here, that they already have been declared. Otherwise, the compiler will not know what you are referring to. So you have to have already told the compiler, this is what a date looks like, this is what a course looks like. Yes, Charles?
When you associate the variable with date, do you have to associate the variable before the struct, or can you do it in main? Like your date of birth.
Mm-hmm.
Do you have to do that in main, or do you have to do that before?
You mean assign a value to date of birth? So that is done in main. Okay, so when you declare a struct, you can't provide values for the variables. You can only, in effect, it's like with a form, you know, if you're designing a form, all you can do is provide the names for the form elements, right? You can't provide default values for them. Okay, I know on a website you can, but if it was a paper form, you can't. Okay, so think of it like a paper form. So main is then like the person that's filling in the field. So it's only in main that you can start filling in the fields. You can't do it beforehand. Now at the time you declare the variable, okay, you already saw there is a way to provide values for, but you have to do something special, and we'll show you that special sauce in order to do that. Okay, so let's say that I have this declaration, and now I want to access a member variable in that nested structure. So I want to assign 1992 as the year in which the student was born. So you just give a period separated list of member variable names. So ST is the student. So if you could look at what ST looks like. This is ST, and it has a name and a major and a date of birth. So it has a name, it has a major, it has date of birth, and date of birth is itself a object that has month, day, and year. Okay, and then there was GPA, and then there was courses, which is a big vector of courses. Okay, I'm not going to write out all the information for courses, but it has all the information for each course. So if we want to assign 1992 to year, we say first ST, then date of birth gets us down to this field, and then year gets us down to there where it becomes 1992. So a period or dot separated list of field names, telling it where to go in the form. Just think about, it often helps to think about, if you're confused, how you would do this in the real world. Let's say that you were on the phone with a friend. A friend called you up. They were having trouble filling out a form. Let's say it was for their driver's license. So you have a copy of the form in front of you. You're on the phone helping your friend. Your friend has a copy of the form. So you say, okay, go down, and maybe on the form looks like this. Okay, it's application for driver's license. I'll just say application. And somewhere in the form, it has date of birth. And in the form, it has month, day, year. So you tell your friend, okay, go find the block in the form that says date of birth. Okay, well, that's what this right here is telling the computer. It says go find the date of birth block in the ST object. Then you'd say, okay, you found the date of birth, and your friend goes, yeah. So now you say, okay, go find the year in that block. Well, that's what this next thing is saying. Okay, you got to the date of birth, now find the year field and fill it in. So the dot notation is just helping the computer navigate to the appropriate field. All it is helping it navigate. Just like you would have to do if you were on the phone with someone, you would have to help them navigate through the form. Okay, so it's just a way to help them navigate. Okay, so we're not even close to being done, so don't, this is just a summary, but we're going to have you work an exercise now. So you have different, actually we'll do this at the end. We'll summarize at the end of class. What we have now is a code assessor exercise to give you some practice with this. So I want you to write a program that's going to read in information about a single student and compute the student's weighted average grade. Okay, so the information, let's see if I can give you some sample data. Sample data might be Brad Smith, and there will be a midterm, and it will actually be named, whoops, no it won't. Let me see. It's not appearing. Okay, let me make it appear. Okay, so it should be there now. It should be called Student and Grades. And actually, if you go to Student and Grades, you will see some sample data there, what it looks like. So the name, Michael Tycoon, and then there's going to be a list of the assessments for Michael. So the first word is the name of the assessment, the second is the score. So what I want you to do is to work through it at your own pace with a friend or friends if you like. I'm going to give you about 10 minutes, and you're not going to get all the way through it. That's okay. We'll probably have you work through the rest of this in the lab tomorrow. But I just want to get you started so that we can give you some help and you can get some initial practice with it. If you have questions or if you're having trouble getting started, please raise your hand. Senior and I are here. We can circulate and give you help. Okay, I am going to just go over the first two parts, give you a hint for the rest of it, and as I say, you'll finish the rest of it in lab tomorrow as well as start lab 10. So, to declare this struct, it's a struct named student with curly braces, and the first two things are the name. So the first two strings are first name and last name. Then it says one midterm. Since you know it's one midterm, you can just put it in a simple variable called midterm. And it says one final, so you can just put it into a simple integer variable named final. And then it says an arbitrary number of homework assignments, which should be your cue to use a vector, because if it's arbitrary, you don't know in advance how many you're going to have to store, so you need the homework. And finally, you need to remember that all-important semicolon. I'm going to leave it off here. And actually, this one's very good. It says error expected semicolon after the struct declaration. Okay, so I compile it, and it's all happy. So that's what the struct looks like. And then it says declare a variable named myStudent of type student. So remember, a struct declares a new type, so that's student. And then that's the variable name. Now, most of the questions seem to center on how you read the rest of the information. The rest of the information is always a string and then a score. The first piece of information is the assessment type. So I would probably, when I was reading the rest of the information, have something like, say, string assessment type, and then maybe have like int score. And then you can say while cn into assessment type and into score. So that will read the assessment type and score. And then you'll use an if statement to determine if the assessment type is a midterm, a final, or a homework. And based on the type, you will do the proper assignment. If it is a homework, you will need to push that homework assignment onto the vector using pushback. Okay? So I'll leave this up. You're going to do it in lab tomorrow. There's one last thing that I need to cover briefly today that you will need for lab 10. Okay? So, and that's not actually in the slides for today, but it's in the slides for Thursday. In fact, I'm going to go straight to the website and show you those slides. So I just need a few minutes. I'm sorry, I'm going to go a little bit over. I know that. I won't go too far over. Need about 5 minutes, though, to go over this one concept, which is important for the lab tomorrow. So it's in Thursday's lecture, C++ constructors. It's only the first couple slides. So remember that when you declared a student, I was showing you that sometimes you could initialize the fields. But I said you had to have some special sauce to do it. So this is, if you're trying to initialize the fields, you put the values you want to initialize them to in parentheses. It's a comma-separated list because it's calling what we call a constructor function. So a constructor function looks just like a function, except that the name of the function is the same as the name of the struct. That's very important. That is what tells the compiler that this is a special function called a constructor function. It is a function that will initialize the fields of your struct. So you give it the same name as the struct. And you put that declaration inside the struct. Okay, so you're putting the declaration of this constructor function inside the struct. Okay, just like a function prototype. And the first parameter is a string, which will be the name. The second parameter is a string, which will be the major. And the third one is a string, which is the grade point average. Do not name the parameters the same as your field names, or the compiler will get confused. You need to use different names. Okay, then outside of the struct, below main, you need to provide a function definition for it. And the function definition, not only is it prefixed with the word student, but it has to tell the compiler which struct it's associated with, which is the student struct. So you say student : Now this may seem silly, but it's not. The reason is that you might want to declare a simple function named student that is not associated with the student struct. So to tell the compiler that this function definition is associated with the student struct, you must prefix the function name with the name of the struct student and : And then you can do your initializations. Hopefully here you can see why it's so important not to give your parameters the same name as your field names. The compiler will get horribly confused if you say name equals name. It won't do the right thing. Okay, and you notice there is no return type. Notice out here there's no void, there is no return type whatsoever. Constructors are very special functions. Okay, once you have done that, you will be able to use this syntax here for declaring your variables. Okay? So that is the special sauce that you need to know for tomorrow's lab. Okay, so see you Thursday. We'll talk more about constructors on Thursday. You'll finish this problem in lab tomorrow. Yes.